Good morning, students. So in our last class, we complete up to question number 2, exercise 6.5 from the chapter application of derivatives, the topic maxima and minima. So today we have to continue this one, and we start today from the question number 3, and the question number 3 is given like in this way: find a local maxima and local minima if any of the following functions. Find also the local maxima and local minima values as the case may be. So now in this case, one thing you see here, don't confuse. So local maxima and local minima. Local maxima and local minima we can find out through the first derivative. If the question is given using second derivative, that means it is simply maxima and minima. So local maxima and local minima we can find out with the help of first derivative as well as with the help of second derivative also. Don't confuse. But in some books it is written as only maxima and minima. So if only maxima and minima written, then we know we have to use second derivative. But sometimes the questions are given local maxima and local minima also. So in this case also sometimes we use second derivative if required. Is it clear? Don't confuse this one. So now here the first question is given fx equal to x square and gx equal to x cube minus thrice x. So in this way 8 questions are given here. So now first question, if you see fx equal to x square, now let's see how can we do this one. So fx equal to x square, it is an algebraic function, so easily we can define set this one, isn't it? So in the first question, if you define set fx equal to x square, if we define set, then f dash of x equal to we get twice x. So now here after this, the first step is what? F dash of x equal to 0 we have to consider. So that's why here we consider f dash of x equal to 0. So when we consider f dash of x equal to 0, so in place of f dash of x we have to put twice x, and after putting this one twice x, so ultimately we get x equals to 0 here. So x equals to 0 is what the we can say here this one is critical point or stationary point. So after getting this one x equal to 0, so if this x equal to 0, again if we put on the given function means which one? Fx, we get only the value is 0. So that's why here written you see, does x equal to is the only critical point which could not possibly the point of local maxima and local minima. Reason behind only one point. So for local maxima and local minimum, at least a range required. So we need the graph. Always when we draw the graph from the left hand side, if it increase, then what we can say? Strictly increasing, or decrease, then it is strictly decreasing, isn't it? Already we know. So that's why here only one point, through one point, it is not possible. Only for that reason, where what you have to do, we have to differentiate the function again. And if we differentiate the function again, so f double dash of x equal to how much we get here? Simply we get 2. F double dash of x equal to we get 2. And after getting this one with the help of second derivative, what we have to do? We have to put the critical point on the second derivative function. So that's why when we put, so f double dash of the critical point is 0. So if we put the critical point 0, so f double dash of 0 equal to we get 2, which is, now you see here, positive. So in case of second derivative, when positive, what we can say? If positive, then minima, or if we get negative, then it is maxima. So in this case we get positive, that means it is maxima. Therefore by second derivative test, at x equal to 0 is a point of local minima, because here it is positive, that means greater than 0. Greater than 0 means what? Minima, isn't it? So local minima and local minimum value at fx equal to f equal to 0. All of you know this one. In first derivative, when greater than 0, it is maximum. But in case of second derivative, when greater than 0, it is minimum, isn't it? So that's why here we get the minimum value is f of 0 equal to 0. Is it clear? So after that, if you see the next question, gx equal to x cube minus thrice x. So again if we define set this one, g dash of x, so the answer we get 3x square minus 3, isn't it? So now after differentiating this one, g dash equal to 0 we have to consider. So when we write g dash equal to 0, in place of g dash we have to put the function 3x square minus 3, and then what we get here, x equal to plus minus 1. From here we get, so x equal to plus minus 1 means here we get two critical point. One is one critical is x equal to 1, another one is minus 1, x equal to. So now here how can we verify in which point, in which critical point it is maximum or minimum? So for that reason here what you have to do, we just put the critical point at two places. Or what you have to do, you can use through second derivative also. So if you differentiate the function again, z dash of x equal to 3x square minus 3. So if we differentiate this one again, then z double dash of x, here printing mistake, here it is not, this one is not z dash of x, it is z double dash of x. So when we write z double dash of x, then 6x we get, and then after that we have to put the critical point one by one. So when we put 1, so z double dash of x, in place of x if we put 1, z double dash of 1 equal to 6. 6 means what? Positive value. If positive value, what we get? Minimum. So that means at which point we get minimum? When x equal to 1. And when we put minus 1, we get less than 0. That means what? Maximum. So that's why from here what we can say by second derivative test, x equal to 1 is the point of local minima, because positive value said it's a local minima, and when we put minus 1, then it is local maxima, and the local minimum value is already here. We find out, how can we find out? When we put the value of x in the given function, then we get the value, and the local minimum value is minus 2 and the local maximum value is 2. I think all of you understood these two questions. These two questions are we solved with the help of second derivative test. Is it clear? Okay, now let's see the third one. So third one is a trigonometric function here. hx equal to sin x plus cos x is given. So sin x plus cos x, and the x is lies between 0 and pi by 2. So what is the meaning of 0 and pi by 2? That means first quadrant. In first quadrant all are positive. That means only the positive critical points we need here. So that for that reason here, first of all we differentiate. When we differentiate h dash of x equal to, we get cos x minus sin x, because ddx of sin x is cos x, ddx of cos x is minus sin x. And after that, now we have to find out the critical point. So h dash of x equal to 0. So when we write h dash of x equal to 0, sin x, cos x minus sin x equal to 0. So from here what we get? Sin x equal to cos x, ultimately tan x equal to 1. And when we get the value of tan is 1, pi by 4. So ultimately x equal to pi by 4. So pi by 4 is lies between 0 and pi by 2. Only for that reason the condition is given here. X is lies between 0 and pi by 2. So the critical point we get pi by 4. X equal to pi by 4. And now after that what you have to do? We have to differentiate the function one more time. So when we differentiate the function, minus sin x minus cos x we get. And then after that, taking minus common, then sin x plus cos x. And now in place of x we have to write pi by 4. And after putting the value of pi by 4, if we calculate, then the result we get minus root 2 less, minus root 2. Which one is less than 0? So less than 0 means what? Maximum value. So that's why our conclusion is what you have to write here. Therefore by second derivative test, x equal to pi by 4 is a point of local maxima, and the local maximum value is what? Root over 2. I think all of you understood this one. So today your task is you have to copy these three questions, and if any queries or any questions are then you can ask me. So the first three questions we solve with the help of second derivative test, isn't it? So with the help of second derivative test we solve these three questions. So you have to practice these three, and if any questions are there then you can ask me. Is it clear? So in our next class we have to continue this exercise, and we start from question number 4. Is it clear? Okay, thank you.